All right, I have 5 o'clock. Time for the last session of our Innovation Summit. And thanks everyone for hanging in there. Our numbers, as usual, stay high and energy strong through the end of the day. And then we'll go into more social activities afterward. But a really interesting application of Lidar and imagery is battling cheatgrass. And I'm happy to introduce Kent Park, the geospatial project manager for Woolpert. And Kent has 35 years in the business here, and he's currently working with Woolpert's in-house photogrammetry and research development for new geospatial products. He's been active in industry forums, subject matter expertise in topics of applications of statewide imagery programs, data fusion, mobile mapping, aerial LiDAR, and USGS's 3-depth LiDAR program. So please check the full bio in the agenda. And also, let's take a look for materials associated with many of the talks alongside the Zoom links in the agenda as well. So with that, Kent, take it away.
Thanks, Frank. Let me see if I can switch screens here. Hopefully everybody can see my screen now.
Good.
Excellent. As Frank mentioned, we're down to the end of the day, and before I got too far into this, I want to say thanks to everybody for sticking around. Appreciate being virtual. Look forward to the time where we can go back to face-to-face, but I did keep in mind that I'm at a critical junction of going from glasses of Coke Zero to glasses that look like this with a little bit more tastier drinks. So I will just set this right back here as a reminder, so I don't go long. But again, thanks for attending, and we'll move forward from there. So again, cheatgrass mapping. As Frank mentioned, 35 years ago, I got started using glass diapositives in stereo plotters, and my career has moved forward quite a bit over the years to film diapositives, along with digital technology and lots of changes. But the exciting news has really been the last 5-6 years, where we've taken digital data such as LiDAR and imagery and been able to extract features, and more refining of that data all the time, to down to where we're looking at cheatgrass, a plant that's about 1.5 feet tall, scattered across the landscape, and we can detect it from QL2 LiDAR. So again, a very interesting concept. We'll go through some of the different phases of this today. So the agenda includes a little bit of everything here. We're going to talk about background of cheatgrass and what it is. Also going to go through and talk about, excuse me, it's all about the data, cover a little bit about how we're doing this, the method for the madness, along with some results and accuracy, and a little bit of twist about where we're able to, right now, be able to look beyond just cheatgrass as far as feature extraction of other plant materials.
We might not be seeing the correct screen, just so you know. We're viewing the PowerPoint out of the presenter mode, just so you know.
Ah. Just a small technical difficulty there then.
Now we've got your notes and your slide.
There we go. How's that?
Yep.
Perfect.
Thank you. So again, what is cheatgrass? Cheatgrass is an annual invasive weed that is not native to North America. It was brought over from Europe and Asia. It's kind of a very, very fine seed, if you will, and it's believed to have been brought over in shipping materials. A lot of packing years and years ago was put on ships, cargo ships, and then onto trains and distributed across the United States. And at this point in time, it actually resides in, or has been found in 49 states across the country. So it's one of those problems that is really spread across the country. The really bad part about cheatgrass is the fact that it greens up very early in the spring, requires very little bit of moisture to do that, but it also dies out very quickly. And when it dries out, it becomes very, very flammable. It's a very fine leaf along with stem product, and it catches fire very easily, and it spreads very, very quickly. Intense heat is generated from it. So again, it's a major issue for wildfires out west, both the mountains along with the West Coast. And that's actually how the project that we undertook got started, was how can we look at finding the cheatgrass to eradicate it, to hopefully cut down on some of the fires that we're seeing out west. Again, regional planning was a lot of the process up front, looking at the research of needs and how to do this. But more than anything, right now we've got about 7 or 8 local and state agencies working in the state of Wyoming on this project. And a big shout out to Karen Rogers for her assistance in getting our first pilots and our first project actually set up in the state of Wyoming. So as I mentioned, it's a very fine plant. Grows somewhere between the native plant, or excuse me, the mature plant is somewhere between 6 and about 20 inches tall every year. On the left, you've got just after green up, you see a little bit of seed left in the top of those plants. And on the right-hand side is the same, the plants somewhere about 3 to 4 weeks later after they've dried out, after the moisture is gone. Again, it likes a very arid climate, but unfortunately it dries out quickly and provides that tinder, which generates a very hot and intense fire and spreads very, very quickly. Where is it found? We've actually isolated where we can find it by using Lidar. So this was actually done through a USGS Gypsy project. About 35,000 square miles of the state of Wyoming was flown for QL2 Lidar. We're using our Leica terrain mappers along with a camera. So we're not only getting just the Lidar, but we're getting imagery with that. So a combination of the Lidar and the imagery allows us to process both data sets and extract out the information. And then the third data set we have is ground truthing. So we've got some university students who have gone out in the field and found areas of infestation and then compared them. We've used some of their data up front to identify, to make the computer intelligent about what cheatgrass is and what it looks like in the imagery and Lidar data sets. And then they collected other areas that were then used as a comparison to make sure that we were identifying just the cheatgrass. Again, a large swath of the state of Wyoming, a little over 35,000 square miles is what the overall Gypsy project was. We actually looked at 3 different areas as far as pilot programs where we first tested the theory out. Can we find cheatgrass and can we help identify it across the state of Wyoming? So again, the USGS QL2 Lidar was done under a USGS contract. The actual identification of cheatgrass was not. So just want to make sure that people don't think that this is one of those things that your USGS 3-depth grant programs will pay for. This was actually funded through the state of Wyoming. So our 3 areas, we'll go over a little bit about those. They're about 5 square miles in each, spread across the eastern plains of the state of Wyoming. This one is close to the town of Chugwater. Again, as I mentioned earlier, it's transferred in a lot of packing material even today. So as the trains and trucks go up and down the interstate, there's a chance of having seed in it, and those seeds being ground to the point where they fall out of boxes and containers. And so it's very prevalent along railroads, along with the interstate. So that's one of the reasons that we've picked some of our original pilot areas. Our second area, again, is outside the town of Harderville. And the third area is just outside the town of Lusk. Again, 3 totally different areas, one of them with the interstate, the other 2 with more of a rural setting is what we see in eastern Wyoming. A little bit of the field survey. Again, university of students went out and identified some areas. Again, this was ground truthing to be able to educate the computer software to find these data sets and look in those areas and say, okay, what is it that makes that data different than the surrounding data? So we took about 20 samples in each of these 3 pilot areas and ingested that back into the computer to allow the software to learn what cheatgrass was before we actually process the entire data sets. Here you can see the infestation right along the edge of the road heavily. Again, in the lower left, you've got the red outline there. That entire area is a cheatgrass, and then the actual picture of it from more of a ground level allows you to see where the cheatgrass is, kind of a yellowish brown on the right-hand side of the grass areas there. Again, it's located all over, but it's more prevalent where we see more of a sagebrush type area. It also is a lot of times found on more of a south-facing slope. For some reason, it does like that southern exposure versus the northern exposure, which would be a little bit cooler. Elevation between 2 and 10,000 feet above sea level. As I mentioned, it likes the sagebrush communities. And then what it really likes is areas that have been barren. So a burnt area, previously fire areas, anywhere we've got development from oil and gas, pipeline construction, roads, things like that. The edge of those areas were not the exact edge or center of the pipe or center of the roadway went, but the edges that were graded made great seed beds for the cheatgrass to get started in, and then it basically chokes out other plants from growing there. So it becomes very populated in these disturbed areas or burned areas. Again, so the relevant data, we wanted source data. As I showed earlier, the university students went out and picked up. The timing of that data collection, we want to make sure that it timed with about the time that we did our acquisition, so that we made sure that the imagery and the Lidar captured the exact same thing that the university students were finding out in the field. And then we use training versus validation. So our training is more of to educate the computer model to figure out, here's what it is, we're training it, versus letting it run and pull out a whole bunch of vegetative data sets and then identify later on. No, we're actually training it versus testing more than anything else. And then there's obviously the classification of identifying the cheatgrass and separating it out from the other data, above ground data that it finds. So again, the supervised classification. So we train the classifier, train the software. We then go out through and classify the imagery, and then we output the results. And we keep doing this over and over. And we don't only pull just the cheatgrass out, but we're looking to pull out anything else that we call as a supervised category. So cheatgrass, water, trees, buildings, roads, pipelines, anything else that we can identify, readily identify, and pull that out to also be able to put that into a classified data set, so that each of those is stored as a different output, and rerun of the data continuously to make sure that we pull out a refined data set that only has the cheatgrass in it at the end. So here is the first pilot area. As I said, it was prevalent along interstates, along areas where they've done a lot of construction. Here would be a prime area. So here's the natural color of that data set. Here is the color infrared of the same area. Here is the supervised classification. So here we've gone through and looked at the spectral analysis. We basically use the USGS 3-depth classifications for vegetation, the low, medium, and high. Particularly interested in that low. Again, the cheatgrass itself is somewhere between 6 and about 20 to 24 inches in growth. So we wanted to classify it all. We didn't need the medium and the high data to look at cheatgrass. We wanted to look at just that low classification of data. And then here is our probability map. So again, the yellow and orange have more of a medium probability. The blue is a low probability, but the red is the very high probabilities. And if you remember right, as we cross the center of that screen from top to left is the edge of the interstate. And then the areas out there that would be flat inside of where the entrance and exit ramps were built up. So again, ground that at one point in time may have been native, it's been disturbed due to road construction, made an excellent seed bed in this case for the cheatgrass to be able to grow. So again, the output, we continue to refine the data set. We continue to add in more and more of the supervised data that was captured in the field to be able to refine it. And we want to make sure that we're not just processing it once and then testing it. We want to make sure that it's refined multiple times. And again, the canopy height model, looking at that's below about a 3-foot vegetation was very critical in this. So we're looking from bare earth to about 3 foot. of height overall to classify this data set. Just a 3D point cloud. Again, this is your bare Earth. And then here's your 2D of that same thing once we actually pull out the bare Earth. And then everything here would be everything that was classified the point cloud above ground of that same area. Canopy, this is the taller grasses are in red and the shorter grasses are in yellow. Obviously, a combination of both cheatgrass and other vegetative species are out there, but we did break it down to red and yellow as far as the taller. The taller was anything up to about 7 feet in height. Again, the results, the red areas are very high probability, and these were confirmed by the field study that was done by the university students. The 98% of the orange areas were also field verified as being cheatgrass infestation in the same area. So the repeated running through this data set, allowing us to be able to train it up front, gives us a very high confidence of what our results are going to be. And more importantly, the repeatability as we take it outside of these 3 pilot areas. Again, just another, instead of the red, yellow showing two green as far as high probability and medium probability. Here's our second area. Again, a little bit different. We've got the road going through there, but for the most part, native ground. So as we look out in those areas, here's the orange for medium probability along with high probability. Again, we took about 20 different field samples from this area. Most of those out in those more native areas that were used to train the original data sets. And then we turned the software loose on the entire 5 square mile area to extract out both the high and the medium probability areas. And area 3, again, mainly native area out here. We've got the road and a farm setting down there. But here we see a very high probability of that cheatgrass. And it actually looks like it was follows a creek that was there, but providing some moisture for the cheatgrass to grow, but it's also appears to be inside of a fenced in area that probably was a field or pasture at one point in time. But again, that's where our highest concentration of the cheatgrass was growing at, was the combination of that water along with that former pasture area. Again, just the high probability in the darker green, and the light green, the medium probability. The amazing thing is some of the other red, as your taller vegetation, those are actually some pines that are out there along the edge of the roadway or between the roadways out there on the top left of the screen. So again, data deliverables, we actually provided a 1 meter grid showing both low, medium, and high probability of cheatgrass infestation. It was all classified as far as the accuracy goes. So again, just a simple analysis relationship between the ground truth and the predictability model of the locations as far as low, medium, high infestations. We also provided a horizontal accuracy, again, very accurate because we're using the USGS 3-depth QL2 Lidar. So we've got a high statistical accuracy on this. And the same with the vertical. Again, we're using that USGS QL2 Lidar, so the Z dimension is obviously very accurate and repeatable throughout the entire project area. Again, the accuracy assessment, 88% overall between the 3 pilot areas, approximately 5 square miles each, and we came out to compared to what the survey crews found, about an 88% overall classification. We did not measure any vertical accuracy. We did measure the horizontal. Horizontal did meet the 95% confidence level. Conclusion, assessment provides a template for use of color imagery and LiDAR evaluation infestation of cheatgrass. But what's really great is it's not just cheatgrass. Our original program here with cheatgrass in Wyoming has now led to a couple of the other counties out there, their weed and infestation agencies are now saying, well, wait, we have the same problem, but it's with Medusa head. So we're now processing Sheridan County, Wyoming, trying to find Medusa head. Very similar to cheatgrass, greens up early, dries out, very, very tender, and expands very quickly as far as fire goes. So the goal across the community out there is to figure out where these areas are at and eradicate them to hopefully greatly reduce the fires that they have out there. Again, the canopy height modeling, slope analysis. Once we actually figure in those two things, especially the slope analysis, our overall accuracy goes up quite a bit. So again, the idea of being able to show areas of future potential invasion, areas that don't currently have it, but areas that could potential based on that slope analysis, along with the image, excuse me, the not the imagery, but the intensity data from the Lidar. So we can use the slope analysis along with the intensity data from the Lidar to look at potential areas for future infestations. Recommendations, it's known to exhibit early green up. We've already talked about that. We actually started with some of the state's regional biologists at the Fish and Game Department. Martin Hicks was a great resource to get started with. We learned there are other types of grasses. Again, we're now looking at Medusa head along with ventonetta, trying to identify other potentially invasive species that, again, create the very beginnings of their wildfires out across the West. The other one, though, we're actually looking at a couple other projects where we're looking at fescue along with some mustards. Another interesting project that we've got going right now, again, using that imagery and Lidar. The great thing is the ground truth signature. So as we've gone out there, we've been able to exclude some of the other features, other grasses that aren't potential problems by, again, through these signatures, through the upfront training of the system. And we learned very early that there's a very fine date timeline there to collect the imagery in the Lidar. Again, we want it as it's greening up. We don't want it dead as winter has killed it off. We want it as it's greening up, but long before it actually turns brown and dry and becomes tender to be able to effectively identify and model the cheatgrass. So again, thank you for coming today. Any questions? I'd be more than happy to entertain those now.
Amy, I think you're on mute.
Hey, Amy, I think you're on mute there, but it looks like Phil Worrell has his hand raised. Phil, do you want to come on camera and ask a question?
Sure. Hey, Ken.
Hey, Phil.
So did you guys do any analysis if you did not have the imagery? Could the LiDAR, the QL2 LiDAR in itself be used?
Yes, you could do it with just the LiDAR. Obviously, your overall accuracy, your percentage of confidence is not going to be quite as high. Relying heavily on the red along with the infrared bands of the imagery to do a lot of the processing of the data set afterwards to, again, increase that confidence level. But the LiDAR by itself, along with the intensity that comes with it, the height model, along with the intensity from the LiDAR data is a great tool to be able to find it. But again, that red and the IR band are just excellent to be able to go in and increase that confidence level.
So if by chance you didn't have coincident imagery, but you had, say, some recent nape imagery or something, possibility then you could use that in conjunction with LiDAR?
We are actually doing a small area up in Minnesota right now for a timber company where we're doing the exact same thing. No recent imagery, but there are some third-party data sets out there. So we're using recent LiDAR data along with some third-party imagery to be able to process for that, yes.
All right. Thanks, Ken.
Yep.
It looks like it had Leland Pierce has his hand raised for a question. Leland, would you like to go ahead?
Hi, Kent. Leland Pierce with New Mexico, specifically Game and Fish. Did you all integrate climate change models on your habitat suitability? Because that's a big topic of discussion, how vegetation could expand under or not expand under various climate scenarios.
Good afternoon, Leland. Good to hear from you. Good question. No, we did not. We have had some discussions. Actually, the Western Governors Council had I think it was their December board meeting, where they actually looked at invasive species, and that's part of the modeling they're wanting to bring into it is more of the overall climate change model and how it can be integrated with identifying more and more species. But we
Yeah,
did not,
I
for
think
this
the
study, we did not.
methodology would be great to integrate into current modeling, because this is really exciting to actually define where it actually is, not kind of modeling where it might be. So
Exactly. I mean, the whole idea of the pilot project here, working with the state of Wyoming, was to identify it so they can go eradicate it, eliminate the fires, reduce the chance of fires. That's the goal. You know, it's not of, okay, we want it just to know where it's at. No, we're actually wanting to go out and take it out. And obviously having that climate data overlaid would give you, you know, a little bit more confidence, a little bit more reliability in the data set.
yep, great work. Thanks.
Thanks, Leland.
All right, looks like Frank has his hand up. Frank, would you like to go ahead?
Yeah, sure. That's great, Kent, because it brings the, you know, the lofty idea of machine, you know, deep learning and AI down to something that's super understandable, you know, and it's so practical. So that's really wonderful. You know, drilling in a little bit more to the spatial and temporal resolution. I imagine when this kind of technique goes to use for lots of other types of vegetation, it seems like the temporal resolution will be outstripping the need for spatial in a lot of areas. So you capture that particular species peak time to identify it on imagery, and maybe peak time to differentiate it as height on Lidar. Can you speak to that and you know, kind of that balance point between spatial and temporal as we look at other species?
Yeah, so we've been working with a couple of timber companies for several years now, and that's actually one of the more challenging things is that window timing of acquisition. You know, as we all know, being able to apply clear weather and no flooding, no snow, etc., makes things a little bit more challenging with it. There's definitely a fine tuning that you have to, but a lot of times it's more of we're back to, okay, here's where we can do it. Let's go capture this data set. But anytime we can, you know, very specific to it, one of our timber customers is actually saying, you know, we're wanting to identify different species of hardwoods, but there's about a 2-week window between one of them starts to leaf out and the other one starts to leaf out. And trying to hit that window is achievable, assuming that they can tell me what the weather is going to be during that same 2 to 3 week time frame also. So obviously all those things go into providing a more accurate and better data set, but some of them are very challenging just to be able to achieve the initial data capture up front. Processing side, it's, you know, we've got time on the backside to process. Don't cause too many problems there. It's more the upfront data acquisition.
Yeah, thank you.
Karen, would you like to go ahead with your question? I see your hand raised.
Sure, thank you. And thanks to Kent and Jeff, and just Woolpert has been amazing partners in this process. And it's super exciting to see, you know, what they have proven with the technology and their willingness to do so. And I just thought I'd share an update of what's going on in Wyoming, you know, given all this. And our governor, thankfully, has taken a keen interest in invasive species. So he convened a task force last year, and we generated a report, and that actually spurned a piece of legislation that has already been signed into law by our legislature in this weird year, that is requiring our weed and pest districts to create a data sharing process for, you know, trying to share invasive species data better, of course, using GIS. And so it's, you know, exciting to see that happen. And I don't think there's any funding attached to that statute, but, you know, hopefully it encourages, I know that, you know, they're willing to spend money on battling invasives. And the idea, you know, the challenge of what this data will do for us is it shows us where cheatgrass is now in this snapshot in time. The challenge will be how to monitor that through the years. And the idea is, you know, cheatgrass isn't just you treat it once and it goes away. You have to continue to treat it for years. And so we'll have to continue, you know, hopefully in a cost-effective way, figuring out where cheatgrass is to figure out what treatment methods are most effective and where they're working, where they're not. So it's going to be a long-term process, but, you know, again, technology is going to help us figure that out. And to get to that timing question of Frank's, you know, timing is, of course, of the essence. And thankfully, we've got a lot of field data collection that Game and Fish and weed and pest people have done through the years to help ground truth and improve the model. So I've helped to put those people in contact with Woolpert so that they can get, some of that ground truth data and improve the process. And hopefully we'll get more money to support the effort and get more products to build better data, better decisions.
Yeah, Karen's done a great job of getting not only the state level, but also the weed and pest at the local counties involved. Again, the connection there, along with the university, being able to send students out to help with the ground truthing, have been just incredible, valuable assets that you've been able to provide. Thanks again, Karen.
Great. Phil, you had your hand up. Would you like to go?
Yep, I'm back. This might be for Karen or Kent. Since it's a small seed and primarily evasive coming from packing, are the transportation corridors your focus, or does it migrate away far enough over time that you're going to have to look at the entire landscape?
We have to look at the entire landscape because it spreads so easily. It's transported by wind, it's transported by birds, by cow poop, I mean, it goes all over the place, by water. Okay. So, it's crazy how easily it spreads. And that's one of the things we pointed out in the report was, you can't be everywhere all the time. So using remote sensing to get that, inventory of where it is across the state is what we need, because there are places that are so remote you don't know. But and so I know with Game and Fish, they have some models of where the most critical habitat areas based on number of, we have species of greatest conservation needs. So how many of those overlap in one area? And then we also factored in precipitation to, what is the danger of cheatgrass spreading? And so, I know the intent is to use those models along with the cheatgrass data to figure out where are the areas that are most important to treat. And then also figuring out, it's, again, that decision of, is it better to treat big areas of infestation, or is it better to spot treat areas where it's new to try to stop it from spreading more? And that's where we are with the Ventonata and Medusa head, is trying to, snuff those out before they get too far.
Great.
Wow.
Yeah. I mean, Phil, I'll fess up on this, on why those 3-4 test areas were along roadways at first. This project came up very opportunistically. We were already there, had surveyors on the ground doing the ground control, and we were already starting to collect Lidar when this came about. So we very quickly sent some spectrometers to our surveyors and said, hey, while you're traveling all over the state getting this ground control, we need you to pick up and ground truth some cheatgrass and find some areas. So roadways are obviously the easiest where we were doing the survey and ground control. So that's why, but no, it's statewide, and our algorithms work, regardless of where, but that's why those were along those very first test areas were along those roadways. It was a kind of last minute opportunistic way to try something out, and it worked. So
great. Thank you.
Well, and at this point, it's not just statewide. I mean, it's across the entire country. I mean, 49 states now have cheatgrass infestations, some of them worse than others. But yeah, it's as Karen said, picked up by wind. I mean, there's all kinds of ways to transport it. But yeah.
Frank, would you like to go? You have your hand up.
Yeah, sure. Karen's comment on just now we need some more funds to really make this the next level. That just sparked an idea that maybe you've thought about, and a comparison of what this reconnaissance activity and the eradication costs versus what the fire prevention or damage might cost, and some almost return on investment. Comparing those two places to invest might be something that could be very compelling. And the other option on that might be there's lots of work with insurance, the not-for-profits that support the insurance companies. So if you're reducing your state's and your citizens' fire insurance risk, that could be pennies on the dollar.
You're exactly right. I mean, it's we're using USGS QL2 LiDAR data. You know, it's coming out of a different funding, so the actual cost to process this is minor compared to the damages that this California alone has sustained just this last year. I mean, not to mention lives, but yes, the cost to process it and identify it. Now the eradication side gets a little tougher because, as Karen mentioned, it's all over the state, and how do you hit all those hotspots? It's very tough to eradicate completely, but over time, I think that would be a long-term goal that hopefully happens shorter versus long-term.
I'm thinking that's a perfect middle school service project contest, turn it into some kind of video game, then your currency is dead cheatgrass or something. Just, you know, get those kids out there pulling it up or whatever. I don't know. That's great.
Sounds like a good Girl Scout project, Karen.
It's funny. I remember as a kid, you know, they're like needles, and throwing them at my sister and I, you know, we would throw them at each other, and because they hurt. So, you know, weeds are not dumb. They're sticky so that they stick to you and gets taken all over the place.
Still on speaking terms.
Yeah, we are. Yeah. Yep.
We had one comment from Leland. Invasive species are like IT. You have to fund maintenance as well. Funding has to include the prevention of the return of an invasive after you've removed it. GIT can help show the cost of nothing doing so and the risk of return without action. Does anyone have any other questions or comments you'd like to address to Mr. Park?
Kind of bourbon you got beside yourself, Park?
If not, I think it's about time.
Yeah. All right. Well, Kent, hey, thank you very much for your time and breaking down something that is some pretty impressive technology into something that's really practical. Thanks, Amy, for your work on the questions. Again, thanks to all of our sponsors. Bridget, is there anything else before we break for the lounge and the hospitality suite at 7 o'clock?
No, I will say that Emily has opened the lounge early. So anybody that is itching to get in there, you can go right ahead. I'll drop the link in the chat in just a second. And yeah, we'll see you at the hospitality suite this evening. And I'll see if Molly has anything to add.
No, this has been such a great day and inaugural Innovation Summit. I think we've heard some really thought-provoking stuff, and I'm looking forward to the lounge and the hospitality suite to have some further conversation. And of course, we'll be looking forward to continuing the dialogue on a lot of these. But thanks for sticking around, and looking forward to the more social parts of the day coming up next.
All right. Thanks, everybody.
Thank you.
Yeah.